Today we'll talk about feral swine. So we're going to the other extreme, I guess, from the talks we heard previously, but looking at the concern, the impact of feral swine, specifically for foreign and emerging animal diseases. So I'll just get an outline, just go through the current knowledge of feral swine in the U.S., touch on foreign animal diseases of concern, and then look at those factors associated with disease spread. Mainly, the concern is, regardless of that disease, what kind of types of things can we do to better control disease spread in those populations, or what would we do if we had an outbreak that involved wildlife. And then I'll touch on the work that we're finishing up right now in California with the wild pig population there. So the U.S. feral swine population continues to increase, and it's not stopping. So right now we estimate somewhere between 4 to 5 million pigs in the U.S. It's very hard to get an actual count of how many pigs are out there. The majority of the pigs are in Florida, Texas, and California. They're exotic, they're invasive, so they're not. They were brought here, I guess, from the Spaniards and brought to the U.S., and then we had populations continue to explode. For Texas, for example, when the market crashed and farmers couldn't pay to feed their pigs, they would let them go. Anyways, but since then we have a continued increase in population estimates. Economic costs, so you'll see quotes from $800 million a year. That's looking at crops. I think Wildlife Services, part of USDA, estimates something like $1.5 billion in damage that feral swine in the U.S. do in the U.S. So just some terminology difference between feral swine or wild pigs in the U.S. compared to Eurasians, boar in Europe. So on the left there is your boar that you think about in Europe. So that's a purebred boar. Those were natural to Europe. In the U.S., we have more of these hybrids, these feral swine that were domestic species that then became wild and can kind of take more of this phenotype seen here, but you still can see the curly tails and the floppy ears. So where are the pigs coming from in the U.S. besides those that were, I guess, initially here or let go or escaped from domestic populations? So primarily in the South we have the feral swine, so they look more like the domestic population. They're usually free range, so they're not on hunting preserves per se, so they're not fenced. Whereas in some states in the north, you have these kind of game ranches, these hunting preserves, where you have animals that are fenced, so these pigs that are fenced in gated areas, gated communities, and people go there to hunt and pay really big money. They think it's somewhere around $500 million plus a year wild boar hunting in the U.S. And so looking at the supply channels for these different hunting preserves, so again in the U.S., mainly feral swine and they're free range. In northern U.S., we have some Eurasian boar coming in from Canada. So we have, in Canada, they raise wild boar there. I think they raise them like 1 pig per an acre. They bred the Eurasian boar with usually a domestic pig or more feral pig that's domestic to get larger numbers of litter sizes. But they do come across to the U.S. California is one of the places they come to, as well as other places in the U.S. We also have movement of pigs, usually illegally. So pigs don't migrate, but they do travel 60 miles an hour plus down the highway. So back of trucks, stuff like that, move out of Texas to other states, out of Florida up to Georgia. We do have an instance of pigs coming from I think Oklahoma and being seen in the western part of the U.S. So there is a lot of illegal movement of pigs in the U.S., mainly because of hunting reasons. So a lot of diseases known in feral swine of concern: swine brucellosis, pseudorabies, lepto, hepatitis E. More recently, anthrax can hit them. E. coli that was found in spinach, so that was shown to be that feral swine can carry that and shed. West Nile, and then some that I'll talk on specifically for this committee are classical swine fever, African swine fever, and touch on foot and mouth disease. So foot and mouth disease. There's going to be a lot of talks on this have already occurred, and then will occur continuously with, or after NIAA with the FMD symposium. But I'm just going to touch on it a little bit, just because of based on what we know about FMD and the involvement of wild or feral swine. So FMD infects cloven-hooved animals. So African buffaloes is the maintenance host. Last outbreak in the U.S., 1929. There was an outbreak in California that involved a park in California where cattle that had FMD were near deer. It was thought that the deer also had clinical signs that were similar to FMD, but they were never diagnosed to have FMD. They still killed a large population of deer there. But overall, it's unexpected for feral swine to be reservoirs, and if they were to play a role in disease spread, it would be limited. So just recent experiences with FMD that involved wild boar, this outbreak looking at Bulgaria in 2011, and so the outbreak was first diagnosed in a wild boar, so it was kind of an interesting outbreak. So wild boar that was hunted was found to be positive for FMD. And then you had 2 different waves of the outbreak in Bulgaria. They do have wild boar in Turkey and Bulgaria. There is a fence line that goes between these 2 countries, and that fence, part of it gets stolen that people use for money, essentially. So there is movement of animals between that border. But we had 2 different waves of the outbreak that stayed in the domestic population. Oh, I can, yeah. My apologies. Thank you. But looking back at that outbreak and the involvement of wild boar specifically, so no virus was isolated from any other wildlife besides that one boar that was initially found from that hunting or that index case. And so introduction of foot-and-mouth disease by wildlife is less likely than FMD being spread because of movement of animals or people on and off different premises. And there was a study that was done and looked back at all previous FMD outbreaks and looked at the literature. And basically it found that FMD is not going to be sustainable within a wild boar population. Or deer as well. So both wild boar and deer were looked at. And if they were to play a role, it's going to be very limited. So if you have a high dense population of wild pigs, it's near cattle, it's near livestock that can be infected with FMD, wild pigs in the U.S. could play a role. As far as the wild pig population maintaining FMD and spreading it or continuing to spread that disease over a large geographic area, was very unlikely to happen. So not so much, though, with African swine fever or classical swine fever. So African swine fever can infect both domestic and wild swine. So the European wild boar do get sick. African wild swine do not. This disease was probably a tick virus that with pigs as accidental hosts, but we do have, so it has a tick component, but we do have competent vectors in the United States. So African swine fever is of great concern. For being introduced into the U.S. Can have direct and indirect transmission, and then both chronic and acute forms of the disease. Can cause up to 100% morbidity, and the mortality varies with their virulence. And so that's the concern with African swine fever is before it was more of a highly virulent virus, where if you eliminate it from the domestic population, if the wild population was involved, it would self-eliminate. Currently, there's more mild virulent strains circulating, and so that lower virulence, there's concern about it being maintained and continue to persist in the wild boar or in the U.S. the feral swine population. And then just looking at the geographic distribution, so previously it was mainly just in Africa, and it has spread out of Africa now. And so there's African swine fever a lot in Russia, and so the concern, a lot in Europe of it coming into the European Union and different countries in Europe, as well as the potential for it coming over in the U.S., potentially in meat or meat products. Classical swine fever, similar with issues with African swine fever as far as the types of strains we're seeing now causing outbreaks, but so it's a highly contagious, economically costly disease of just swine, so both wild and domestic pigs. It's RNA virus similar to BVD, which we have in the U.S. So last time we had ASF or CSF in the U.S., we eradicated or declared free in 1978 after a 16-year eradication campaign. It cost about $140 million. At the time, we had about 1 million feral swine in the U.S., and we would see, it would be reported that the clinical signs seen in domestic pigs were similar to what was seen in the feral swine population, but the feral pigs were never tested as part of that eradication effort. Back in the 80s, after we declared free, we went back and did serological and virus isolation studies on just a handful of pigs, I think 100 or so pigs between some of the states that were affected, and there was no virus or serological surveys that had or that isolated classical swine fever. So at that time, we'd assumed that if CSF was introduced into the feral swine population in the U.S., that it would self-limit or not sustain. The virus there was more highly virulent than what we're currently seeing in the world. And so this is looking at where CSF is right now. The concern is that it's very near our borders. But it's worldwide distribution, very ease of access to that virus. And again, the current circulating strains are low to moderately virulent, which may delay detection, but also help persist that virus to circulate in wild pig populations. So looking at what they're experiencing in Europe, so the outbreaks don't necessarily self-limit, looking specifically at wild boar populations in Europe. And so on the map here, these darker areas are areas where they've had outbreaks in domestic as well as in the wild boar, but the dark areas are in the wild boar populations where the disease is continuing to be maintained and continuing to persist. So Germany, for instance, had 59% of the outbreaks due to direct or indirect contact with affected wild boars, and so that's partly due to the production types that are there where you can have that occur. In Italy, they had to make it illegal to hunt wild boar populations because the hunters were spreading those populations over greater distances, and subsequently the disease was also spreading over a larger distance, and they couldn't get control over it in Italy. And so looking at all those outbreaks, and the concern is trying to identify what factors that influence disease spread in feral swine, looking across those diseases I just mentioned, that in hopes that we could identify what those factors are, get more information and more data about them, that we could use them for disease response or preparedness efforts. And so, looking at disease spread, especially foreign animal disease spread in feral swine or wild boar in Europe, we know it's their population distribution and density are very important. Their social spatial structure, their movements, habitat connectivity, and then that interspecies contact for those diseases that affect multiple species. And so I'll just quickly touch on some of these of what we currently know about these factors in the U.S. So their population distribution density, so we know they're not continuous across the U.S., so they pick certain areas that they like to be. They really need shade and water, the two main things, and then a food source. Again, when they move or come to new areas, you can have some natural dispersal from existent populations, but mostly it's because they're moved by humans or from hunting into new areas. I mentioned the European wild boar importation from Canada that comes into the U.S. They're extremely adaptable. So in Texas, they're now in West Texas, so in the desert, we have populations which before we did not. And human environment change has really made a habitat that is favorable for feral swine, so irrigation, stuff like that, crops, makes it a favorable habitat for feral swine as well. Their social and spatial structure. So they travel in social groups called sounders, which is usually one or two sows and her young. So the age makeup of those groups are mainly young, so it's mainly the younger pigs with a couple of the adults. The males usually stay with the group till about a year, 18 months of age, and then they leave. Usually they travel on their own or maybe with one or two other boars, and usually they're related, so it's usually the pigs are in the same litter. They're somewhat territorial. Kind of depends where you go geographically, how much there is overlap between that habitat. And they're usually nocturnal, so that's more true in Texas and California. I can say they're not. So we have had movements of the pigs throughout the day. So their population dynamics. So the big concern is that they are the highest reproductive capacity of all large free-ranging mammals. So they can have technically up to 2 litters a year. Usually it's 1 or 2 litters every 18 months. And then the average size is between 4 to 8 piglets per year. And so you'll see estimates, just looking at those numbers, that the populations can double in 4 months. That's given, pretty perfect habitat type and food availability. But based on that, the numbers, to get it at the current status quo, you'd have to kill 70% of the population of what it is now, which is basically impossible. Their populations are resource-driven, so if there's a drought like Texas had, or if there's less water, their populations will decrease. But again, because of their reproductive capacity, they can increase their numbers very, very quickly. their movements. So they're pretty sedentary within their home range. So they don't go out and move randomly on the landscape. When they are moving, they know where they're going. They know that habitat really well. When they go between different preferred habitat types, these are riparian areas, going along rivers or streams. When they're in those areas, they're rooting around, they're hunkered down. They're not moving too much, or when they do move, they stay in those shaded areas. When they're moving in between preferred habitat types or those open areas, again, you'll see, if you go out, you'll see those trails of feral swine movements, but they know where they're going, and they know their habitat really, really well. And their habitat connectivity, so that's basically looking at the connectivity of populations across the landscape and trying to identify where those habitats potentially overlap. That you could have different different contact between different social groups of pigs, and that's important for disease spread. Of where you have that contact, the disease could spread over a larger geographic extent. So we can't have interaction between social groups. A lot of times we're seeing that occur at common feed or water sources. So like your at a common water source, where right now we're trying to identify that where it is that you'd have overlapping in home ranges. So the sounder groups or those social groups are more likely to have overlap, what we're seeing in the data, compared to the boars. So they mainly stay, even if they're close, in geographic area to each other, they don't typically cross home range or areas where there would be potential contact. And then the intra or interspecies contact, so looking at diseases like foot and mouth disease, where you could have, the cattle contacting the pigs, or have deer as well coming in contact with feral swine. So that can happen. For the intra-species contact, the concern there would be, some of the backyard swine operations. A lot of those in Texas as well, and other states. But that contact there between, the wildlife and the feral or the backyard pigs. And so when you look at all those factors and then look at those diseases that I just mentioned earlier, you're trying to identify that interplay of different components of the virus itself comes into play, as well as with the different aspects of the wild pig population that would get to a point where you have the sustainability or the spread or the persistence of these viruses within these wild pig populations. And so looking at things like their ecology, so how they breed, how that changes based on hunting, how you can have many susceptible pigs, especially if it's a lot of piglets, because you decrease population sizes. Having a virus that is, is more of a moderate virulent strain, so you have more chance of susceptible animals coming into contact with diseased pigs. Having high density of local aggregation, if you're setting out different corn for hunting, like we could do in Texas, or different areas where you have aggregation of different social groups. They're basically looking at all these different factors that could lead to that sustained transmission chain, where you have a larger outbreak where it's spreading over a larger geographical area. And so the problem, and what led to the study that I'll touch on a little bit in California, but in 2009, Government Accountability came out with a veterinary workforce document and stated that if wildlife became infected with a foreign animal disease, response would be greatly complicated and could require more veterinarians and different expertise. And so our current U.S. response plans, so you're supposed to assess the risk of wildlife present and strategies to prevent the domestic wildlife interaction, but we're not sure exactly how to do that, and when, what resources you would do to do that, and how you'd actually, quantify what that risk is, and then how to mitigate that appropriately. So things that we do not know. So if a foreign animal disease became introduced in this population, what would happen? So would it fade out? Or would it become endemic? How long would it take for us to detect it? So usually when people see dead pigs, that's a good thing. So would that actually be reported if it was a foreign animal disease causing that death? Where would there be potential domestic wild pig interaction? And then what types of control and mitigation strategies would you implement based on that disease in that location? And so what we found out, there was really lack of data to develop a wildlife epidemic model which you could use to address some of these questions with confidence. So that gave rise to our motivation for this study that we're wrapping up right now. It's a California Wild Pig Project. And so our approach was to collect empirical data in California on wild pigs using global positioning systems, geographic information systems, a lot of mapping, and then some landscape genetic work. And then our data collection analysis are based on those factors I just mentioned that are known to be important for disease spread. So looking at their habitat, their movements, their contacts, and their population connectivity. So just brief information about wild pigs in California. So their population is somewhere between 200,000 and a million. Again, that population fluctuates based on habitat quality, food availability. Again, they're non-native invasive species. We call them wild pigs in California versus feral swine because they really are a hybrid between the Eurasian boar population and the more domestic type pigs. And it really depends on where you are in California and how that morphology changes. So some central areas in California, they really have those longer noses and kind of have more of a European look than some places up in North and Southern California. But we have year-round hunting there. There's no bag limit. I think that's pretty common in a lot of states where you're allowed to hunt them. But you do have to pay a pig tag for each pig in California. So I think it's $23 per pig right now to hunt California. That can be contentious with some of the landowners who are trying to control their populations. But that information, when they submit a tag to the Department of Fish and Wildlife, now I think, so Fish and Game in California, you can put the location of where you shot that pig, and they can keep counts of the kills in each county, which is nice to keep up with, kind of where the pigs are being killed. But this map is, which is what this map is representing, but it is biased because it's not taking into account the public lands that pigs usually migrate to when they're being hunted on private lands. And so what we did is we had 3 study areas representing 3 different ecoregions. So we had a lot of talks before we started the study with Wildlife Services, with the Department of Fish and Game, to identify areas where you have, a lot of different types of ecoregions, landscapes, habitat, rainfall. So we could start to tease out what these different factors within the landscape that affect the movement and contact of wild pig populations. So we chose these 3 ecoregions in California to do the study. We sampled both sounders and boars, so basically we had GPS collars. We trapped pigs within these 3 ecoregions. So we do 1 pig per sounder group. So we put up the wildlife cameras and make sure we're getting different sounder groups, and then do 1 collar per sounder group. And then any boar that we trapped, we put a collar on. And so the collars would stay on for 10 weeks. That was a function of the battery, of how long we could get that data, and also our data collection schedule. So we took GPS locations every 15 minutes between 7 p.m. and 7 a.m., and then every hour between 7 a.m. and 7 p.m. We took blood samples. We worked with Wildlife Services, and they did testing on ASS, FMD, CSF, and these other diseases listed here. And then again, we took some genetic samples. So always be careful where you place your traps. So also trapped a lot of wild calves in my study areas. But the cattle really like the traps as well. And so the data analyses that we're wrapping up right now, we're looking at analyzing their movement patterns, so how they move through different habitat types, looking at factors associated with habitat selection, so where do pigs spend their time, and then habitat connectivity. And so again, for this study, and it was funded by Department of Homeland Security, so they were interested in having data that could be used to develop a conceptual, and then a computer model of wild pig populations. So we could run these different scenarios and look at different outbreak situations. So right now, a lot of our data analyses are focused on those parameters that would be used in a wildlife disease model. So for the movement parameters, looking at the movement, comparing day and night, weekly, a few days of movement, and the by hog type. So if they're, male, female, young or not, and then if they're a boar or in a sounder group, and then identifying the different environmental and seasonal assessments of how those factors affect that movement. And then again, looking at the probability of contact between those different social groups of pigs. So this is one of our study sites in Mendocino County, so in Northern California. So that star there is San Francisco. So this is Mendocino County, so it's about 2 hours north of San Francisco. So just show you what some of the data looks like. So we have 4 traps out here. So this is one day on August 12th, looking at 4 different pigs. So we have a boar here that's all in yellow, so it's the same pig, a boar here in green, there's a sow here in red, and a sow here in purple. And so looking at just a snapshot on one day, those pigs are pretty far apart, not coming into contact. Other parts during the day, during the time, they're all aggregated in certain common areas. So what we're trying to do with those analysis is identify where that occurs. So where is it that you have pigs come into contact? So you could use that to know when you have higher risk of disease spread, or use that for your control and mitigation strategies. So that's just showing all the data of the GPS for this one study site. So just go through some of the data analyses. I'll just point out a couple of things here. So one of the things is looking at the distance traveled. So currently there's a handful of wildlife or wild pig models that are out there that use that really look at the or incorporate the movement distance that pigs move. And usually they use just a kilometer. And so what we're seeing from the data is that really varies based on both region and by hog type. So we have the boars that move greater distance, which we know that, but now we can start quantifying what that actual number is. So up to 9 kilometers in this North Coast study site. That was a heavy forested area, so a lot of cover. So the pigs were moving longer distance in the covered areas versus some of the Central Coast where you had more kind of unconnected habitat types, and so they moved less, and usually it was like a 2-mile radius for their home range. And then we have some Texas data that we're comparing this to as well, to see what the difference is between those states. And a lot of this data analysis is very similar to what we're seeing in the Central Coast in California. So other things we're doing with the data is to look at those factors associated with habitat selection. So again, identify what's in the landscape that affects where you find pigs. So if you had a new area where you thought there might be wildlife, you could take what we're learning from here and help with looking at or analyzing maps to see where you might have feral swine populations. And so basically this is just GPS data. This type of analysis where you look at this resource selection functions, but basically identify what those resources are in the landscape that pigs select and which ones they don't. It's used a lot in conservation management or conservation ecology, where you'd put different corridors to maintain the population connectivity. And for feral swine work, we're trying to do the opposite. So identify those areas where we could disconnect those populations if we needed to, especially for a disease outbreak situation. So just an example here, so if you had 2 different populations, if this was a species you wanted to conserve, you look at putting corridors here to try to connect those populations. So where the green are is where you're most likely to have this species. So you look to put a corridor maybe right here to try to connect the green essentially on this map. For the pigs, we'd want to keep it disconnected. And again, looking at the population connectivity, so the genetics can help us with this, to identify the different populations that are more similar to each other over a larger landscape. So not just this data collection is not just with the GPS data. It's working a lot with hunter groups to collect the genetic data over a wider area. But basically, what we're trying to do with the genetic data, or hope to do in the future, is to identify these different nodes, or basically these different patches within the landscape that could hold a population, and then identify how related those different populations are based on that genetics. So you could start connecting the dots here, essentially, and knowing who's related to who, but basically trying to identify what's the characteristic of that landscape that would make populations come into contact or be connected, and then identify excuse me, where you'd have certain areas where if you took out that habitat patch or that area, you essentially could disconnect, this population from, this population down here. So, if you could, put artificial barriers there, that might be helpful, or identify areas where you'd focus surveillance efforts. So if you had to go and test pigs, where would you go look? And so identify those different places where you could either implement those measures if you needed to. So implications for foreign animal diseases. So understanding potential foreign animal disease spread requires knowledge of the pig distribution, so just knowing where the pigs are. Also need to understand their movements and potential contact, so you can understand or better quantify what that spatial extent of disease spread might be, especially if you do have concern that a disease spilled over into the wildlife or other way around. And then identify areas of increased disease spread so you know where to look. So where we could go out and get samples where you would test. And again, so identifying areas to focus mitigation strategies for that last map I showed you. So looking for areas where you could disconnect subpopulations of wild pigs if you needed to help control control the spread of disease. So future directions with this work. Again, I mentioned the Texas data, so we're doing a lot of comparisons of the data in California to Texas to do some generalizations of types of data that you need to collect in other states. Hopefully. Inform future data collection efforts. We anticipate to develop a wildlife epidemic model using these data or informed by these data, so we can run different scenarios for animal disease outbreaks that involve wildlife populations, identifying that domestic wildlife interaction, and then again being able to assess different disease control strategies. So just some acknowledgements. So again, the California work is funded by the Department of Homeland Security. We have one of the researchers in the room, Pam Hollinger. So she's involved in the work. And then we've had a lot of collaborators in California, especially with Wildlife Services, Department of Fish and Game, and some of the pig trappers there, and a lot of landowners that allowed me to come on and trap their pigs and then release them, which was not always smiled upon.